guys, welcome back to my channel. So today we will talk about the structure and the function of heart. What is heart? What is the heart? The heart is basically acts like a pump and takes all the blood and circulates it throughout the body. Takes oxygenated blood from the lungs and circulates it throughout the body. Here I have drawn the heart. So let's see how the blood flows through the heart. So first we would see, let's say this is your body. Like here is the tissue. They took in the oxygenated blood and converted it to deoxygenated blood. So this deoxygenated blood comes through the superior vena cava and the inferior vena cava. Superior vena cava is for the upper body, for your head and neck and all that, and inferior vena cava is for the lower body, like the knee, legs, etc. So here deoxygenated blood comes and goes into the right atrium, where it then passes through a valve. What is a valve? Valve protects a liquid from going in one direction and only allows it to go in one direction and prevents it from going in the other direction. So in the tricuspid valve, it could only go from the right atrium to this right ventricle. It could not go from, let's say, from the right ventricle to the right atrium. Okay, and you might be probably thinking, why have I written right like this and left right like this? It is totally wrong. But if you hold it like this, my right is actually towards here and my left is towards here. So this is correct, and we're seeing it like it was like a person has laid down here. So it passes through this tricuspid valve. It is held together by some strands known as chordae. Okay, so the deoxygenated blood came into the right atrium and was pushed to the right ventricle, where it went through the pulmonary semilunar valve. What is this pulmonary semilunar valve? Well, this pulmonary semilunar valve takes in the blood from the right ventricle and pushes it up and to the two lungs. Now, it goes to the two lungs, where it goes to the alveoli and other things and takes in the oxygen and comes back through this pulmonary vein. This pulmonary vein then comes from both directions like this, and then this goes to the left atrium, where this is again pushed to the left ventricle through the bicuspid valve. Then this left ventricle contracts and the blood goes through the aortic valve, aortic semilunar valve, where it then goes up and goes up through these, like this artery is known as aorta. It is the largest artery in the human body, and the vena cava is the largest vein in the human body. And this aorta, as you can see, has this this thing, which is for the upper body, and then this descends. This is actually known as the descending aorta and goes to the lower body. Okay, so now this is these are capillaries. These capillaries take in oxygenated blood, let's say from the arteries, and these branch off. And let's say these are tissues here. These tissues take in the oxygenated blood from here and take out the deoxygenated blood, and it flows through a vein. So now it comes back through these capillaries and then comes back to this inferior vena cava and superior vena cava. And the aorta also branches off into the coronary arteries, which provide oxygen to the cardiac muscles. So let us know some things about the heart. It is found in the thoracic cavity. Something we call the thoracic cavity. It is the chest cavity basically. So it is found in the thoracic cavity. It almost weighs about 200 to 300 grams. And yeah, so this heart, so the most powerful, so this right here you might think is the myocardium, the muscles of the heart. These are used to push the blood throughout the body. We could see that it is thick in the ventricles and thin in the atriums. Why? Atria. Why? This is because the atria need to only push the blood into the ventricles. But the ventricles need to either push it to the lungs or throughout the entire body. That's why it is thicker. The myocardium there is thicker. So you might have heard doctors putting stethoscopes onto our chest and listening for sounds. These sounds are there are two sounds dub dub, like you could lub dub, like that. So the first sound that you hear is the lub, and the second sound that you hear is the dub. What are these lub dub sounds? Lub sound is first happens when the tricuspid valve and the bicuspid or mitral valve shuts. It produces a sound and it is lub, like lub. And the second sound is dub when the pulmonary semilunar valve and the aortic semilunar valve close shut. This produces the dub sound. So this was heart. So now you might think, how does the heart work? Like you know, muscles, like they need to be connected to the neurons in your brain to be fired. Like if I'm contracting, my brain sends a electric pulse through my spinal cord and through neurons to contract my hand. Then how does the heart work? So basically there is this thing called the SA node or sinoatrial node. This basically takes in ions and takes out ions, specific ions, to create a potential difference, or also known as voltage. So this basically produces a voltage here. So what happens? This is independent from the brain. Okay, so this is independent from the brain. Only thing that the brain can do is control the rate at which it pulses. So what happens is, because of ion exchange, it takes in specific ions like calcium and takes out the ions and produces a voltage. So it fires. When it fires, it actually causes the contraction of the muscles, the heart muscles. Basically how I contract my hand. So it causes the contraction. As we can see, this is positioned in the atria. This node is connected to a thing called interatrial fibers. These fibers allow the electricity to be conducted throughout the atria, so they contract at the same time. So they contract at the same time, so they push the blood out of the atria, and now it goes to the ventricles. Now it also comes to the AV. Then this SA node also has fibers called the internodal fibers, and these come to the AV node. This or atrioventricular node. This actually delays the message, and then this goes to the bundle of His. This is basically just the structure, and then it divides into two fibers called the left and right bundle branches, and then it goes throughout the low ventricles, like around the ventricles and in the myocardium, and this again divides into what is called Purkinje fibers, to basically spread out it so that the ventricles contract, so all the myocardiums contract evenly. So basically after this happens, it delays it so that the atria could contract, and then it delays it and then goes through the bundle branches and then goes through these. The ventricles only contract and depolarize when the electrical signal goes up. So it contracts like from bottom to top to push the blood onto the pulmonary artery and the aorta. So this is basically what happens. This is the electrical activity that controls the heart. So we could also read this electrical activity of the heart in something known as ECG or electrocardiogram. So here is what a ECG of a normal person looks like. In the ECG of a normal person, it kind of looks like this. Like that. So here we have the P. This is known as the P. In here, what happens is the SA node fires and basically tells the atria to contract. This happens and atrial depolarization happens. And then this is known as the PR segment. It is just the time, because once you fire the signal, it takes some time for the muscles to contract. So there is a delay between the P and the R. So this is known as the PR segment, and the atria contract here. Then we could find the QRS complex. This QRS complex is basically when the ventricles contract, ventricles depolarize. So the AV node has delayed the signal and it goes through the bundle branches and through these, the Purkinje fibers and the bundle branches, and the ventricles depolarize. As you can see, this is much higher than the P wave. This is because the ventricles, as I said, had more muscle mass, because they need to pump the blood throughout the body. Then after this, there is a delay, and in this delay, this ventricles contract, and then there is this T wave. This T wave is ventricular repolarization, basically like the ventricles relax. So the ventricles repolarize. But you might be thinking, why don't the repolarization of the atrias show up in the electrocardiogram? Basically, because of its because it has a very small mass, it basically is very small, and you could basically see it, but it is outblasted by the QRS complex, which is very large. Now we move on to blood pressure. What is blood pressure? It is basically the pressure in our arteries and veins. So what is you might have seen blood pressure things, and you might have seen doctors writing it 120/80. What does this mean? 120 means the systolic blood pressure, which is during the contraction of the heart, where the blood pressure is higher. So we could see that the blood pressure here is greater than here. It is expressed in the units of millimeters of mercury, because earlier we used mercury because we didn't know about its toxicity. Anyways, we could see that this is always higher because the heart always contracts, and the lower one is known as diastolic blood pressure. This happens because this happens during the heart between heartbeats, basically. So the blood pressure is low here. Yeah. So now we move on to the arteries and veins. So arteries actually carry oxygenated blood and veins carry deoxygenated blood, but there are exceptions to this. And as you can see, this is the pulmonary artery. And you know, the pulmonary artery carries deoxygenated blood, pulmonary artery causes deoxygenated blood. And we could see the pulmonary vein. Pulmonary vein takes in oxygenated blood. So, why are these named like that? Because if you're moving away from the if you're moving towards the heart, it is no it if a blood vessel is going towards the heart, it is known as a vein. And if a blood vessel is moving away from the heart, it is known as an artery. So here I have a vein and an artery here. So in the vein, you have very thick walls because there is a lot of pressure in the veins, in the arteries. So there are thick walls. And lumen is basically the space in the blood vessel. So these have a very small lumen, like very small. And these have no valves. And they have a high pressure, as I told. But we have this vein. These veins have a very thin walls. This is because they don't carry as much pressure as the arteries, and they have a larger lumen, and there are also valves. Now you might be thinking, why are there valves? Because they have such low pressures that if they go up, there is a chance that they might go down. So there are valves to prevent it, so that it goes back into the heart, and then the whole cycle repeats again. I hope you enjoyed this video, and I will see you next time. Bye.